We are providing the single biggest piece for human comfort, which is we're washing all of the materials in the house with slightly warmed or slightly cooled air. So we're getting all the surfaces in the house to be even. It's called mean radiant temperature. Robert Bean taught this to me years ago. It's dead freaking nuts. Like when you start experiencing it, you're just like, this is amazing. This shouldn't be, but it is. It just is. And so 60% of human comfort is radiant based. We have about 150 or 160,000 temperature sensors in our bodies, mostly in our extremities, hands, face, feet. And if those are happy, we're pretty much comfortable.
Hey everyone, 2 quick announcements before we start. First, and I'm a bit embarrassed to say this, for the last couple months we've been trying to hire a new senior iOS engineer. Last episode we announced that we had hired someone. He was here 3 weeks. He was awesome. And then some flashy new venture capital and private equity backed startup with no product and no customers offered him a giant increase over what we were paying him, and he left, which that's just a huge gut punch. We offer very competitive market rate stuff, but irrational behavior like that, like we just couldn't compete with. We're trying to build a business that is just built on solid fundamentals. I say this because so much of this podcast is, frankly, Eric and I learning alongside you all about how to build a great business. So many of the tips that we get are just about business in general. And I know that for many of you, hiring is your single biggest struggle. So I give you that unvarnished update because we feel lucky so many of our guests have shared so much with us. And so it's the least we can do to do the same. We're asking for help again. If you all had a referral that you didn't send in, or you think of anyone else that would come to mind, we'd love those referrals. We're looking for a killer senior iOS engineer. The job spec is in the show notes. Sorry to take your time with this again. Thank you for understanding, and thank you for your help. Okay, on to happier news. The U.S. Heat Pump Summit is coming up. If you like this podcast, you're going to love the U.S. Heat Pump Summit. And frankly, so many of the people who have been on this podcast are going to be at or presenting at the U.S. Heat Pump Summit. Eric and I went last year, and it was an awesome event. The caliber of attendees and the caliber of speakers was through the roof. If you're focused on building a big and successful heat pump business that does right by homeowners, you're going to find your people at this event. It's in Worcester, Massachusetts in November. The link is also in the show notes, so go to it, and we've got a discount code. So if you go and you buy tickets, use discount code AMPLY, AMPLY, all caps, to get a discount on your ticket. And we hope to see you there. All right, thanks so much for listening. On to the episode. Hi, and welcome to the Heat Pump Podcast. I'm Ed Smith.
And I'm Eric Fitz. We are co-founders of Amply Energy.
And so today we have the one and only Nate Adams, widely known as the House Whisperer. Nate, welcome back, but this time as a solo guest.
Yeah, I'm not going to be arguing with Alex Meany this time around, but that was a lot of fun. I'm glad we did that.
Yeah, that was an awesome one. Nate, you're a man of passion, mission, heat pumps, electrification, but you're not a traditional HVAC installer. Like, tons of people know you, but tell us a little bit about your backstory, where your interest, expertise comes from, and what you do day to day.
Okay, I think I'm going to take it back quite a ways to having an extremely mechanical father, like obnoxiously so. I'm like Michael Jordan's untalented son when I compare myself to my dad mechanically. Like, he was just this savant. Like, I've met a lot of mechanical savants at this point in my life, and he still stands out like as special because he could look at almost anything, tell you how it was made, tell you what the defects were. He was unbelievable. The wildest thing he ever did was he restored a 1911 Mercedes that had a carburetor that no longer existed. So he had carburetors from 2 other cars of the same year. So that was a 90 horse one, and he had ones from 50 and 70. And he had a pencil drawing from a brochure for this car. By the way, this car was so expensive that the Kaiser of Germany bought the step down. This was a really expensive car when it was new. And so he figured out, he'd never made a carburetor before, and he figured out how to make it and machine it. And it turned out there was one in the Indianapolis Motor Speedway Museum. So he and I drove out to Indy. The mechanic there pulled the thing off. He measured it and photographed it. He was within 8 hours of machining after 200 something hours of machining to create this thing. of having it perfect. So that gives you an idea of where I come from. But one of the things that he talked about a lot was if you're struggling with something, observe it. If you can't figure something out, just keep staring at it and turning it around in your mind. And I think of making a 3D model of things in my mind so I can spin it and then I can begin to pull things apart. So fundamentally, that's a feedback loop. And so if you're having trouble understanding something, you want to just study it and look for feedback loops and just try and peel things apart. And so while personally he was incredibly hard to deal with, that part of him was amazing. And he taught that to me. And I've brought that into my work here. So like I look back and I just see that again and again. So like I get into so many freaking fights. It seems like I'm always in a fight. And fundamentally, it's usually
On
about
social media.
Yeah, exactly. Yeah,
Yeah.
not physical fights. That's not really my style. Usually it comes down to I have watched something and watched it operate and tried to study it and understand it. And I've measured things that few people have done. And I've come to different conclusions. And then oftentimes I'm arguing with people over, I call it arguments over specification sheets. The specification sheet says that it should do this. And I'm like, I ran it and it did this instead. So therefore I win because I actually watched the thing operate and I understand what it's doing. So that kind of just background is really important. So as far as professionally, things fell apart with my dad. I was working for my dad, fell apart, and I went to work for a fiberglass distributor that sold fiberglass insulation to contractors that were building new homes and insulating them. And started learning building science at that point. The housing crash came, my job disappeared. 2 weeks later, my wife's job disappeared in user experience and graphic design. So I started a retrofit insulation company. I was planning on doing it anyway. I was miserable at the company that I was at. It was like Office Space. I had 5 bosses. So somebody was always mad at me, but they never talked to each other. And I'm like, look, I'll do whatever you want, but you got to talk amongst each other and decide what you want me to aim at, and I'll do that. So it was just miserable. So I was ready to jump anyway, lost the job. And in doing the retrofit work, I've always been someone who seeks excellence. And what's the best way that we can do things within reason? So not necessarily perfection, but excellence. There's a difference between the two. And all too often I was hearing back from clients that when I was insulating, things were getting worse. And what it turned out to be was I was reducing the heat load of the house, so the equipment was running even less. So like particularly it was additions that come to mind. So additions, like they almost always get hacked in as far as the ductwork goes. So they just get taken off an existing trunk that already, all the airflow was already spoken for. So if the equipment runs even less, that room gets colder still, because it already needed more flow than it was getting. And as I started pulling all this together in my head, I also met my old partner, Ted Kidd, who fundamentally taught me house whispering. And I was then miserable doing the insulation contracting because I was working 80 hours a week trying to keep my crew working 30 because the job size was too small. Fundamentally, it was what the challenge was. My average ticket was $2,500. I was working too hard to try and get the work because insulation as an idea is usually worth somewhere between $1,000 and $3,000 to most homeowners. That's about it because it's just an idea. They don't really feel the difference. When you get into true home performance and solving problems at their root, all of a sudden it's not insulation, it's improving comfort, it's improving health, it's making the house a better place to live. And now like 10 grand's oftentimes where it starts. And at the time, my average was $28,600 for a job doing house whispering, which doesn't sound like much today, but this is 2018. That was a fortune. So the average ticket for HVAC was like 9 grand. So I was doing 4x that plus. But in doing all of that, it was really interesting to learn what was possible and would move the needle and what wouldn't. And try, because that's not like $100,000 or $200,000 budget or $1 million budget for some of the deep retrofits that you see sometimes, which those are never going to go anywhere. And honestly, even the milder ones, I don't think are going anywhere. I think we have to deal with things from an HVAC perspective for the most part, for better, for worse, just being pragmatic years later. But something that ended up frustrating me with the house whispering, you'll hear me constantly being frustrated. I'm always like looking for whatever the next thing is. I do something for a few years and I get bored and I want to figure out what the next piece is. And yeah, I can do these really cool projects. And my closing ratio was really high. It was 92% from plan to project and about 70% from lead to project. So Pretty good, above average. But I can only do 10 or 20 of those.
You're making me feel bad.
Those are unusual. And remember, this was a lot of content marketing on my part. My little website was getting 30,000 hits a month, talking about like attic ventilation and various things like that. It was shell focused because that's where I come from. And The HVAC is absolutely critical to providing comfortable, healthy homes. And what I wanted to see was anyone who wants one can get a truly comfortable and healthy home. That has really been my thrust for years and years. I've tried multiple paths to get there. None of them have worked. But to a degree, like you said, the one and only, I'm well known in the space at this point, but it hasn't been financially successful and it hasn't moved the needle nearly as much as I'd like to see yet. And so that's what I continue to strive for. So as I move out of creating a contractor business model, I'm moving back to consumer education because like most consumers don't know what a good system or a good install is. So I'm going to be working on teaching that. So anyway, it's fiberglass insulation to installation contractor to house whispering to trying to figure out an HVAC business model and now back to consumer education. And then I also do Airbnbs with my wife, very cool themed, all electric. So of our 5 houses now, I've pulled gas meters on 3 of them. And I own a crap ton of heat pumps and dehumidifiers. So I think we own 12 dehumidifiers now. That's a lot
Wow.
for one person.
Yeah.
But yeah, it's been an interesting path forward. And then through all of that, we were talking about by text, like to me, what one conclusion that came to was one-way air conditioners. So here's a reversing valve for a heat pump. So this turns an air conditioner into a heat pump. Like, why do you want a piece of equipment that can only do half of what it's capable of? And in northern climates where we only do 4 or 5 months a year of cooling, you're not even getting 50% use out of that piece of equipment. When for $150 in parts, you can get full use out of it. So like that had been scratching the back of my mind for a long time. I finally figured out a way to put it that was useful in 2021 and did a Twitter thread on where I thought that the manufacturers should get paid to stop making air conditioners and only make heat pumps moving forward because it's such a small change. It's a very low cost thing to do. And that turned into a paper. And then it's actually turned into 2 Senate bills after that. One called the Heater Act, the other called the Cooler Act, because heat pumps are cooler than air conditioners, which cracked me up. But those are not going to go anywhere in today's political economy. But I'm glad that those at least made that. But back to my thrust of creating comfortable, healthy homes for everyone, that's part of that because the right system will do that for people, or it will help a great deal. Because houses can still be too leaky to actually really deal with. But even if you take a really crappy house and you put a good system in it, it'll be decent, if not good.
Awesome overview. And one thing that you didn't hit on in there, comfortable, healthy homes for everyone. You seem, based on your social media presence and I'm talking to you, like electrification is a key aspect of that for you. Like where and why does the focus on heat pumps tie into this?
That's a good question. It's funny. It goes back to an inconvenient truth. Al Gore convinced me years ago.
Al Gore.
Yeah. I
Yeah.
still don't like him. I think he's hypocritical. I find him highly annoying, but I can still respect somebody's thoughts and arguments, even if I have trouble with the rest of them. And one thing that really hit me through that too was from a conservative perspective, stewardship really hits me hard. Let's leave things well for the next generation. Let's not use up too much of what we have. So that was a key thing. And then the other thing was just looking at the economics of clean energy. Clean energy now is the cheapest form of energy in human history, and it's still getting cheaper. This is where we're going. Cheapest and most available resource wins. Last I checked, pretty much all of us have power lines to our houses. So it's available. And it is the cheapest if we can not have the utilities be stupid, which is out for debate at the moment. But it's where we're going to go. And then the experiences of it are better. So a heat pump done well is a far better experience. An induction cooktop is better than gas in almost every way. It's nice to see the flame, get a visual indicator of what's going on. So that's one thing that, yeah, I'll grant you. But induction's nice. It's easy to clean. It's easy to adjust. It's instantaneous. Like, it's a lovely thing. Electric cars, I'm a car guy. And it's funny, you start getting these arguments of, but it doesn't make noise. But when it comes to being a car guy, it's usually about speed. There's nothing faster than EVs right now. The Tesla
Yep.
Model S Plaid with a 190 to 60, and I don't even remember what the quarter mile is. It's 8 or 9 seconds. It's just obscene that you can get a four-door sedan to do things that like Ferrari and Lambo can't match. So the electric products are just fundamentally better than the fossil fueled ones in general. So yeah, there's some exceptions and there's some use case challenges. Like I drive a pickup truck. I don't want to drive a pickup truck, but I tow 20,000 miles a year. I got to drive a pickup truck. It just is. And like electric trucks don't make sense for that use case yet. Just that's a bad use case for them. So you have to recognize where things are good and where they're not. But yeah, electrification, I view it as both a green thing economically rather than a green thing environmentally. It's the environmental thing is nice, but it's good for outdoor air quality. It's good for indoor air quality. So if we're talking about clean air and clean water, it's really good for that. There's all of these things where it's like when you step back and you first principles everything of where we're going and what's the best path is, it's just electric. Like this is not, it shouldn't have been a political thing. The political stuff drives me bonkers. My pinned tweet for years was be careful politicizing heat pumps and electrification. We have now done that. So we're seeing the results of that everywhere. The UK, there's a huge backlash. Germany, there's a huge backlash. In the US, there's a huge backlash. And it's because we're using the wrong freaking language. Don't act like you're selling CrossFit or veganism or a religion or something like that. That is the wrong way to come at the mass market. But that is a lot of how the tactics have been the last few years. Sadly, as far as like decarbonization within our lifetimes, we've probably blown that shot at this point, which is a bummer because if the Heater Act had gone through with the IRA, that would have changed everything from an air conditioner to a heat pump, and 2050 would have been on the table. So like it wouldn't be a sure thing, but say 1 in 10. But now it's 1 in a billion. I don't see any daylight for getting there by 2050, which is a bummer because it's where we should go, just from a pragmatic thing.
Ed was jumping in and saying there's so many different topics you raised there. When thinking about how politics have come in to kind of influence heat pumps, that it definitely is a complicated issue. When I step back and look at the market, forget what is happening in politics, the market has spoken. And for the last 2 years, more heat pumps have been shipped than conventional furnaces, and that trend continues. And I think that's really about when you look at just the product and the solutions that heat pumps can offer. They're more comfortable. They can solve a whole range of problems for homeowners. And so that's promising from my perspective, that there is definitely progress. And yeah, there's certainly some questions about if you are thinking about the decarbonization side and the targets that are very important for us to hit. There are definitely some challenges there about hitting certain timelines. But I'm still, from talking to various folks who are installing these systems, talking to homeowners who have them, there's a lot of great stories out there too. And progress is being made, but not as fast as we'd like.
So I'll push back on that because the heat pumps versus furnaces thing, I honestly hate it because it feels like you're looking at two things that are dissimilar. It's what people who argue with causation and correlation all die. Like I think a lot of that bump is because mini splits have gotten more popular, but a lot of mini splits are installed in cooling only uses. And I wish we could see deeper into the numbers, but I can't afford to buy the numbers from Hardy and see what's actually going on. And the slope of that line is not particularly fast. It's 6%. But I can't see that slope continuing because we're going to be getting to the Midwest, which has cheap gas and one-way air conditioners, basic single-stage stuff. Like, I don't think we're going to tear into that. The Midwest is the one to break. That's the hard one to do. Now, there are some contractors out there doing it, and I do love seeing the positive things being said about heat pumps now. Because when I first started arguing on HVAC school back in 2017, holy cow, the pile-ons that happened. What? You're an idiot. Like, that's at least moving, and that's good. But there's still a lot of, no, I don't want one of those because the liberals want the heat pumps. And it's my background leans politically right a little bit. It was a lot, and I've moved to just pretty much dead center at this point. But like, we're arguing over reverse gear in a car. I don't want reverse in my car because the liberals want that. Like, what? It's a technology. It's reverse gear. Like, what, you're going to push your car out of the parking spot every time? You have to use a pull through. There's no way around it. This is dumb. Why are we arguing over this? Like, we are the only market in the world that doesn't run basically all heat pumps because it's such a small change between them. I mean, like,
Yeah.
you can
Yeah.
still buy a mini split heat pump for $600, the whole freaking system, at Home Depot or Lowe's right now, or like a Mr. Cool, God forbid. We don't want to dive into that. Anyway, like, why is this politicized? It's like reverse gear in a car. It is so dumb. And then when you look at the feedback loop of, if you actually watch runtime in a house, which is what I've done for years. I think I shared the presentation to you. I presented to the local ACA group in Cleveland in 2016 about watching a runtime, like seeing when things slid and looking at the output curves of the heat pump and seeing what the actual load was. Like, okay, that's really close to what we predicted, or that's too high, or that's too low, whatever it is. When you start looking at what houses actually need, you're going to find that furnaces are stupid for most homes. It's the wrong piece of equipment. It's like needing to drive a trim nail and getting the sledgehammer. It's the wrong tool. So, like, why is this? Just go freaking measure. Just go watch. And like, when everybody who does comes back and, yeah, I see what you're seeing. Is it every house? No. If it's a leaky house, yeah, you're going to need more. But then I keep seeing load calc. So we'll come around to Manual J now. Like, I get given a Manual J and I'm like, dang it, that's at least double what reality is.
Good. This way to bring it around. I was about to do that. So we could go down, you're preaching to the choir on this podcast, at least on the value of heat pumps, so that we can come into some of these interesting political topics in a second. Let's go into this Manual J thing a bit. So let me just tee it up. There's been a lot of stuff on social media lately about Manual J. And without naming names, my interpretation of a bunch of it was, I've seen X number of Manual Js. It didn't seem like a big number. 3, 5, and they were way too big. And I've got a rule of thumb methodology that I like, and it seems better. We should throw out Manual J, which there's then that sparked like a flurry of back and forth. And Nate, one of the reasons we love you is like, you watch stuff, you practice stuff, you share your experience. And it's one of the reasons we love having our software in your hands. You tell us what you like and what you don't like, and you don't pull punches, and it's always valuable. Whether we agree with it or not, it's always valuable. Would love your perspective. I'd love to have a dialogue, frankly, about this sort of the Manual J questions. Okay, so you were just saying you've seen a bunch of Manual Js and they're always too high. Tell us more about that and your read on where we need to go.
Wonderful. So I should start off with, Amply has shifted my thinking much more than I thought it might have. Thank you for that. Because my assumption with seeing things be so wrong so often, like twice as high, that's where I see things. That's like the median, if you will. So sometimes I see where it's only
median.
Like 50% or 75% is high.
Yeah.
I've seen some where it's 2.5 or 3 times too high. And you're just like, what is going on here? And I've used a bunch of tools. I've used Energy Gauge, I've used BOPT, I've used Treat, I've used basically every Manual J tool out there. And they all seem to overstate heat load between 40 and 100%. Every single one. Until you true it to reality. And the best reality is usually energy use. I like to know blower door, energy use, and thermostat set points. Because sometimes, like I had one client, his gas use was low, and I'm like, where do you keep it set at in winter? 55 degrees. All of a sudden, 800 therms was a ton, where before it wasn't that much. So like you need to know what the outliers are. But in general, most people set between 65 and 75. And so you have an idea of what's going on. But my goal in load calcs is to be within about a half ton of what actual heat load is. And heat load is almost always higher than cooling load, although it's not as much higher as I thought it would be. Like I keep watching houses and finding it might only be 25% more than cooling. It might be the same as cooling. Occasionally it's less than cooling. One of our houses here, it's less than cooling because we painted it a dark color. It's brown. So when it gets to be 85 degrees, the shell of that house gets hot and that air conditioner runs his brains out for 6 hours. And that surprised me because I was literally standing in the house watching the equipment operate and feeling like the warm spots in the house. And this is how you learn. You have to inform your intuition constantly. But I want to be within a half ton because any closer than that's dumb. You can't buy equipment less than that. And usually my biggest decision is it going to be a 2-ton or a 3. That's almost always my decision, because it's shocking how many houses are there. And the other piece of it is, so let's not talk rules of thumbs. Let's talk heuristics. It's a better word for it. So I just recently got a Manual J in the Chicago area. It's for a brand new house. It's ICF foundation, 2-inch foam board under the slab house, R49 spray foam with a roof, 1,700 square feet, got a 45,000 BTU heat load. So my check figure in my mind is for a tight new home in climate zone 5, we should be around 1,000 square foot a ton, give or take, as a heuristic. So it's a check figure. I'm not saying that's how you should size, but when you see 400 square foot a ton or 300 square foot a ton, you're like, wait a minute, we need to go look at what these numbers are and try and figure out what's going on. And so the slab,
Nate, just to jump in for a sec, this point is so important that these heuristics, these rules of thumb, whatever you want to call it, these gut checks, these sanity checks, are really useful when applied correctly. When they're used as this sanity check, as this is weird, I need to dig into this more kind of thing.
Yes. Yeah, don't size with this. I'm not saying size 1,000 square foot a ton. I'm saying have check figures in your mind. So like retrofits in Cleveland, I usually found that I was sizing at 600, 800 square foot a ton. That's just where it came out. Is that always what it is? No. And I want to check the math. So when you're sizing aggressively, you need to know your math. You need to reduce your risk so you don't get callbacks. But here's a key thing to ask you. So I pulled my first client gas meter in 2014. The most aggressive one that I did was I put a 3-ton Carrier green speed in a house that had a legitimate 50,000 BTU load. And ended up doing, it was a baker's dozen of electrifications. Guess how many times when we were as much as 25 degrees below design temperature in Cleveland, any of my clients' houses slid when they didn't want it to.
That their thermostat dropped. By slid, you mean thermostat went below?
Exactly.
Set point.
The thermostat wouldn't hold set point. Yep.
My guess is, knowing you, that maybe no times that in this scenario.
Zero. So they may have used a lot of resistance. Hallie sure did. Woo! But she also told me that is the only house that she has ever had where she had to either check her phone to see what the temperature was outside or step outside to understand what the outdoor weather was. That is a comfortable home. And that was a mid-60s, 3,000 square foot split level that we did reasonable air sealing job on. Nothing super exotic. But it's all feedback loops.
So you did have electric strip backup on it that could have jumped in when the heat pump couldn't keep up. Yeah.
Yeah. Okay. Honestly, resistance is not futile is my joke for anybody who likes Star Trek. Always have resistance if it is an option. If it's a ductless mini split, it's not an option. But if you have a ducted system and there's a slot, put 3 kW or 5 kW in there, because guess what? Someday the compressor is going to fail. I hope it's 25 years from now, but someday it's going to fail. And now it's an annoyance, not a crisis. And that's also something we should talk about with versus furnaces. When the furnace goes out, do you have backup? Nope. When the heat pump goes out, when the compressor dies and you have resistance backup, do you have backup? Yep. It costs 2 or 3 times as much to heat the house, but your house is warm. And at the end of the day, hot showers and cold beer, like Amory Lovin says, that's what people want. So it's just critical to do that. But the reason that I undersized so badly, by the way, was so that the equipment was running 100% of the time. So this is where I think we need to shift the conversation. Equipment should never, ever shut off if we can. It's actually pretty much technically impossible because we have so many hours where we're below 3,000 BTUs a load, and there is no equipment that's good at that. Most climates in the US have 2 or 3 months where we're talking near zero heating and cooling load, is what it is. But if we can at least get to 50 or 60% runtime, which requires being very aggressively sized. That can be, you have to put a 2-ton heat pump on a house with a 3-ton load to even get to 60 or 70% runtime. But when we do that, what we're doing is we are providing the single biggest piece for human comfort. which is we're washing all of the materials in the house with slightly warmed or slightly cooled air. So we're getting all the surfaces in the house to be even. It's called mean radiant temperature. Robert Bean taught this to me years ago. It's dead freaking nuts. Like when you start experiencing it, you're just like, this is amazing. This shouldn't be, but it is. It just is. And so 60% of human comfort is radiant based. We have about 150 or 160,000 temperature sensors in our bodies, mostly in our extremities, hands, face, feet. And if those are happy, we're pretty much comfortable. Right now, my knees are cold because I've got crappy windows and I've got my window cracked and it's a little bit cool outside and it's starting to hit me because I'm wearing shorts right now. I can be very aware of where my physical comfort is. And if we can get the equipment that runs all the time, we will have really comfortable clients, even in crummy houses, even with crummy ductwork. And to run 100% of the time, we have to size it as aggressively as we possibly dare, and then probably go another size smaller. So that's why I am so anal retentive about how small can we possibly make the equipment. I'm chasing comfort. Like I said, my goal has been for anyone who wants one, I want them to be able to have a truly comfortable and healthy home. Small equipment is the single biggest factor in providing that. Small and variable speed and fully communicating. I put a Bosch in this house. I'm about to rip it out and put a Carrier green speed in. That should say something. I have a 4-year-old heat pump that I dislike enough. I'm going to remove it. And I don't even know if I'm going to reuse it in the near term. I think it's going to go sit in a shed because it won't dial down as much as I want and it won't dehumidify. And then like in heating mode, it basically acts like a single stage piece of equipment. And my house is not as comfortable as I would like it to be. Like I know what's possible and I'm missing the mark. And initially when we did this, I didn't think this house was going to be where we'd live. So I'm like, it'll be an experiment. Now we live here and I don't want that piece of equipment because it won't load match.
Nate, let me jump in because you have taken us on a remarkable journey in so many points. We started with Manual J and it was tends to be high, and you want to be within half a ton. You took us to heuristics, rules of thumb, things that let you sense check numbers to come out of a complicated model is basically what that is. The importance of those guys, your philosophy on sizing, put in a heat pump that's undersized, back it up with electric strip heat. But there's like all these trailheads I want to go back down because that house you started with in Cleveland or Chicago, I think you said it was 55,000 BTUs and you put in a 3-ton. But I don't think your point was that's actually the load was. I think your point was you put in an undersized system and you had electric KW. So I'm not sure you knew exactly where that difference was, but talk about feedback loops. Talk about like why doing a load, putting in system, observing it, like what about that is so critical for you that you think more HVAC contractors should be doing and maybe even the powers that be observing as well to inform stuff like Manual J.
Yeah, sorry. I've been hitting broadly, trying to sketch out like all of the thought processes that are behind this. Like when I say something, there's probably a great deal, many hours of thought behind it to come to those conclusions. So hopefully that's coming through to a degree, which also makes it hard to keep me on point.
No, it's not the ravings of a madman. It's the ravings of a man who cares deeply and has experimented countless times. And this is a topic that is near and dear to your heart. That's how it comes across.
There you go. Yeah, it's the mad scientist, but the mad scientist who cares.
Yes.
And also is trying to figure out how to think about scale at the same time, which is a challenge. But back to your question. When you watch equipment run, you will see that you have oversized pretty much 100% of the time. I've seen a couple of houses, like old leaky houses and brick houses can be really challenging. Brick houses have a bunch of thermal mass, so they're awesome until they genuinely go cold. And then the only solution to them is a crap ton of BTUs. It just is. They're weird to watch. They break all the models. Our models don't take thermal mass into account well enough. But in general, you're going to watch houses and be like, yeah, put a 70K furnace in that. But it looks like my actual load's 2.5, 3 tons, maybe 3.5, maybe 2. And you'll start getting more comfortable with downsizing. But this is also where hybrids end up being a really nice thing because great, put the 60K furnace in, whatever. I don't care. Because if you put a 3-ton heat pump on top of it, like a 3-ton heat pump and a 60K mod furnace, that system will work in 80 or 90% of American homes right now. And it'll do a pretty good job. I'd prefer to do a 2-ton or not even have the furnace, but my preferences don't come into play here. But if you watch houses and you watch the equipment run, you're going to get much more comfortable with sizing smaller. And if you can get a heat pump, particularly into your own home, I don't think you've had Jim Bergman on yet, have you? Or
No, we
did you?
have.
Oh, that's right. Yeah, because
Yeah.
he was saying like we need to talk about like when we're wrong, we need to talk about it even more loudly than when we're right. And his point was basically me busting his chops for years until he put a Bosch heat pump in his last house. And it was so funny. We had lunch one day and he's like, Nate, that stupid heat pump cost me $20 more last month than it did if I'd run the furnace. But he just told me like the furnace would wake him up almost every night when it kicked on. And the heat pump never shut off. So he was okay with it. And he's, my basement has never, ever been warm since I've had this house for 15 years. Now the basement's warm. And I'm like, Jim, we're sitting at lunch. We just spent $20 a person and you're whining to me about $20 for the month? Shut up. And so we've become good friends. He's so funny. And in his new place that he just bought, he just put a hybrid in there too. And the conditions weren't right for him to to start the heat pump up. It was too cold. So he just ran the furnace. And one day it hit 65 degrees. So he went out and he started up the heat pump. And I wanted to call you and tell you that you were right, which is wild to get from Jim. But I can't believe how much more comfortable this house is with this heat pump than it was with the furnace. Yeah. It's unbelievable to me. And like I've seen that again and again personally, and until you experience it, you just don't believe it. We're all doubting Thomases.
I want to unpack this very specific point about getting more comfortable. I'll call it right sizing or downsizing or being more aggressive with your load calculations. I think that's what you're trying to say. And that word aggressive I think is very important. I actually want to quote Manual J itself. This is in the very beginning of the latest version of Manual J. It's actually page 23 for those keeping track. Manual J says, be honest and aggressive. Manual J is an engineering tool that has an inherent and appropriate factor of safety. Any attempt to add other safety factors or to manipulate the procedure may result in unacceptable performance, especially in part load. And Manual J is super clear about this. And so let's talk about what do we mean by being aggressive? What when you're doing a Manual J, what does that mean?
Well, so let me give you an example so I see lots of heat loads that come in between 60 and 80,000 BTUs. And so let's use a 67. So when you get a 67,000 BTU heat load, what are most contractors going to put in? They're going to do a 60 or an 80?
They're going to size it up.
They're going to do an 80. But I just,
or 100.
Yeah, or even 100. Yeah. Let's just be sure.
Yeah.
But the reality was 30. Now, that isn't something that I should hammer on like super hard because you're not going to have shells like that in a lot of houses. But let's say that the load was 45. Putting an 80 in is a disservice to that client. That house should get a 60. That's the challenge. But the reality was a 3-ton heat pump was the right piece of equipment for that house. You never would have expected that. But from an engineering perspective, that was the right answer. So we are using the wrong answer so often. And a lot of that, like that's what that post from Eric Reinhardt, I believe it was on LinkedIn, that just went wild. He said the load calcs are a significant problem. We're never going to electrify with the numbers that we're getting. And he was criticizing loads that he was getting, which is what I'm doing. So like the one in Chicago that was 45,000, we ran our own and we got 21 using Quick Model. And so I was back to what we were originally talking about, like where you guys have helped me adjust my thinking. I thought the formulas were just wrong. I still think they're probably too conservative, but I don't know that they're as conservative as I thought. And then the other challenge is to get within half a ton. We have to, how can you leave out air leakage? Air leakage is between like 20 and 70% of the heat load, depending on which house you're looking at. It might even be as low as 10. So if we don't have that number, how can we be accurate? How can we be proper?
I think I'm hearing from you, and I want you to correct me if I'm misinterpreting. What you're saying is that Manual J math generally is pretty solid, but it's the inputs into the model are what really matter. And so if you've got bad inputs, if you aren't taking into account what the actual insulation is in the attic or in the walls, or that you've got whatever type of windows, or you are taking a total guess at how tight the home is, that's where you get into trouble. And that's where folks end up inadvertently putting in, really oversizing in general. They end up putting in their own factors of safety essentially into Manual J. Is that what I'm hearing?
Yes, for the most part, I think that's what it is. I still think the formulas are probably a little too conservative, but I don't think they're as conservative as I thought before I started playing with your tool. Because this 45,000 BTU Chicago house I was mentioning, the duct loss was too high because it was modeled outside the envelope, but it was a spray foamed house, spray foamed roof. So it can't be outside the envelope by definition. The mechanical ventilation load was too high. The infiltration load was too high. And like all of these things add up, and we knocked out a little over half what the load was. So yeah, those are input challenges to be sure. And I think that probably is the biggest thing. And that's where my thinking has really shifted, to be frank. And I'm sure Wes Davis will be glad to hear this. But still, how do we do it without some kind of check figure on what the air leakage is? And past energy use to me is a really good check figure to get an idea of, is the house really leaky or not? Are we always going to have it? Heck no. We need a modeled answer because we aren't going to have all the data that we want in many cases. But if we're going to say proper Manual J, if we don't have either a past energy use or a blower door check number, because that's like half of the equation, I don't think we can call it proper. So we need the inputs and then we need that check figure, whatever it is.
I think there's an important nuance here too, is that, all right, I just want to talk for a second about what factors of safety. These are things that have been in place. It is an engineering practice. They are a very good thing. Back in the turn of the century, when we were first building using metal railroad bridges, and the sort of civil engineering practice was starting to come together, factors of safety weren't being used. People talked about riding on a train and going across some of these bridges. It was terrifying. Like, bridges were failing all the time. And so there are a lot of great practices that have been put in place for when you are modeling or designing something, and it is impossible to fully model 100% of the real world, or it's extremely expensive to do that. So in any model, based on engineering principles, there are usually some form of factors of safety. And Manual J has factors of safety. From what I have done for my own research, looking at other large sample size research studies, on the heating side, it's somewhere between 20 and 30% factor of safety for the heat calculations. That does vary depending on your climate zone. There's a lot of different variables that are going into how large that factor of safety could be. And that factor of safety is there because we assume in a home, like if you do some verification of like how much insulation is in the walls, we generally assume, okay, you've got that insulation is present in the entire building. But in practice, if you open up walls at various points, for whatever reason, maybe you're blowing in dense packed cellulose and multiple bays could have been missed for whatever reason. Or during construction, an entire section of a ceiling may have never had the fiberglass bats laid down for whatever reason. And so those factors of safety are in there to just protect us a little bit for those things that we just can't see in the walls and that we can't easily verify. And they're really good. And so Manual J in particular is providing this guidance to be aggressive because it already is putting in these protections for us to make sure that we're not having a surprise when we do Manual J. And then the other piece that I wanted to say that's very important is to separate Manual J from Manual S. Manual J is about the home, and Manual S is about what's the right solution, what's the equipment that is appropriate given Manual J. And there's very specific guidance and protocols on the Manual S side that help us also think about, okay, what are the loads, and therefore what should we be thinking about from a equipment performance perspective, given my climate zone, given my altitude? Other things we need to keep in mind. So I just want to make sure we're not mixing the manual S and manual J concerns too much.
No, I think that's fine. I should talk about manual S in a second. But one bit of pushback on the safety factors is no one's going to die. The worst case scenario is instead of the set point holding 70, it slides to 65 or maybe 62. No, like death is not something. We're not talking a train falling into a crevasse.
It is, but they're in there because heating and cooling systems actually legally are considered a health and safety piece of equipment. There are a lot of places like their renter protections. You know,
Yes.
if you have got a medical issue, and that's why they are built in, because they actually view it as a health and safety issue.
No, and that part's correct. I guess it's a question of what it is. I'm also thinking, remember reading that the Brooklyn Bridge was supposed to be 6 times stronger than was actually needed, but then they found out afterwards that the steel was half as strong as they thought. So they're still okay. They're still 3x, but it's good to put some extra in there. But that's, to me, it's a little bit different. Anyway, so, and then on the same subject, talking about resistance backup, which I don't think people think about. How many BTUs is 15 kW? It's 51,000, give or take. It's 17 kW per 17,000 BTUs per 5 kW. That is a lot of backup, considering that a shocking number of houses probably have heat loads under 50,000 BTUs. I'd argue basically anything built since 1980. So like in Cleveland, that's when we went to R11 in the walls and R30 in the attic, and modern platform construction with plywood. So basically construction hasn't markedly changed since 1980. That's 45 years ago now, almost 50 years old, are quote unquote modern building practices. And those houses I find are usually relatively tight. We're not going to say great, but like I think in a ratio on blower door of CFM 50 to above ground square footage. So like we had a cool old 1835 house that was 2,200 square feet above ground that had a 3,800 blower door. So that's close to a 2-to-1 ratio. 3,800 to 2,200, or I mean, like a 2,000 square foot house with a 2,000 blower door. That's a 1-to-1. I find that modern building construction is usually somewhere 2-to-1 and under, oftentimes close to the 1-to-1. The 1-to-1 came up in my mind years ago for building science reasons because 0.35 ACH natural, which is where you need to introduce mechanical ventilation in BPI standards, like I kept watching the auditor reports and it was really close to square footage. 1,500 square foot house, 1,400, it'd be a 1,400 blower door would work out to 0.35, something like that. Is it dead on? No. But again, check figures. That was my check figure in my mind is 1-to-1. And then in doing the house whispering, when I got a house to 1-to-1, it was very controllable with HVAC, where when it was well above that, it wasn't. And so from 1980 to today, a lot of these houses are good enough that we can do a huge service to customers by putting the right piece of equipment in that runs a lot, that's right sized, and we can solve all kinds of problems with HVAC alone, which messes with my mind because I come from the shell side. I want to fix the shell first. Everybody should air seal and insulate, but realistically, no one's going to. I've come to that conclusion after years of beating my head against the wall. So in sizing stuff, we still just aren't sizing aggressively enough. So how do we get people to realize that they can size much more aggressively? And the feedback loops are the biggest answer. Put echo bees in if it's single or 2-stage equipment. Put in a couple of energy monitors. Do your own house. I'd say everyone should start with their own house because if you screw it up, you can fix it. And then know that 15 kW is 51,000 BTUs. 10 kW is like 33 or 32. So my favorite backup strip is a Carrier, which is a 3-stage. It's 369 kW. That is like perfect for so many systems because I really like reheat dehumidification, which we can do another episode. But 3 kW is less than a ton of output. So the system can match that really nicely and run at 50% capacity and just suck the moisture out of the air and get a nice long runtime so that it does a good job on that. Like the systems that I use, they don't use a whole lot of power for reheat at the end of the day, where if you try to do that with a single stage piece of equipment, like it can be an utter train wreck. Like resistance backup is just something we should use a lot. And that also fits in a 100 amp panel. Like there's all of these pieces where when you start watching, you start seeing here's what the sweetness is. Like a 2-ton heat pump with a 369 backup is an incredibly useful piece of equipment. Will it fit every house? No, but probably hit 40 or 50%. That's a big slice. That's 50 million homes in the US where a 2-ton with that backup is probably the right piece of equipment. But if you aren't being careful with the Manual J and it comes back at 50, 60, 70,000 heat load, you're sure as hell not putting a 2-ton in.
This is, Nate, we're coming to the point where we should probably wrap up a bit. But I want to summarize, because we've hit a bunch of stuff. First of all, you're awesome. Thank you for joining.
Oh, you guys.
Appreciate that. Second, feedback loops, right? Don't just take gospel, go put stuff in and see how it runs. And it's more than just, did I get a call back or not? See how it's actually running, put in a Ecobee, put in an Emporia energy monitor, whatever it is, to see how it's actually holding up based on what you thought. Second, Manual J, the math isn't wrong. It's often like misused or misunderstood. There are these factors of safety in there. And so folks are layering in more factors of safety. If they're being not aggressive but conservative, you're going to get a massively oversized system. And you said this a few times, like that's a disservice to a homeowner. Be aggressive came out multiple times. Be aggressive with your Manual J. Be aggressive with the equipment you're putting in, especially on the heat pump side, but not so aggressive with the electric strip backup, right? Like a 10, 15 kW,
whatever.
That's going to provide a ton of BTUs, and that provides the peace of mind for the homeowner. Rules of thumbs are useful checks, but they should not be used for sizing. Just a ton of awesome points. Eric, anything that came to mind for you that we should mention too? Because we hit on a bunch of stuff.
Yeah, I think it's worth just on this point of being aggressive and like what that means. Manual J itself actually gets into this in a little bit more detail to clarify what they mean by that language. So when you're putting in your inputs, like that's really what you need to be really watching carefully for Manual J. There's software out there that does the math for you. It's the inputs that matter. And so on the cooling side, the example that Manual J provides is you're in the home and you're noticing they have drapes on the windows. Assume that those drapes are actually going to be used at least half closed or even fully closed. Most normal people at design conditions, when it's wicked hot out, they're going to close their drapes. So between the two of assuming they're going to not use their drapes at all, or if they are going to use their drapes or blinds, like assume they're going to use their blinds on their windows for your calculations. That's an example of being aggressive. Same thing on the heating side. If you're hopefully with every project, you are poking your head up in the attic and you're at least taking a quick look to see what you've got going on for insulation up there. Same thing, you're like taking off an outlet cover in a wall. You're putting in something non-metallic just to double check. Can I pull out some fiberglass hairs? You're verifying like there is any insulation at all. And if you see that there's some there, use the assumption that's like slightly more aggressive. So if you're not sure if it's R21 or R30, go for R30. That's the more aggressive assumption to use.
That's a great example.
You will end up with a properly sized, correctly done Manual J.
If you have that check figure, though, I'll push back on that. I still think you need to know something about past energy use or air leakage, or at least make a somewhat aggressive. How about this? Make an aggressive assumption on that. Like 1980 to today, you can probably be more aggressive. Although, so let me give one key piece here. My strong climate bias, which is hard to kick, is climate zone 5. So I'm used to a cold climate with hot, humid summers and all the ductwork inside. As soon as you get down south and you get leaky ductwork outside, you better know what you're doing. But the good news is most of that stuff is easy to do. If it's a flex duct system, seal your boots, seal your joints. There's not that many of them. If you're replacing the system, at least take a quick look at them. It doesn't have to be that hard. You can seal boots in a couple hours in most houses. Seal the freaking boots. But know where your biases are and try and fight them and be aware of them. But we really need some other check figure. With infiltration being 20 to 70% of the load, if we have no idea what that number is, we're going to be too conservative. So I would generally lean more aggressive on that. Down south, you're going to have to pay attention to duct leakage, yeah, but you can visually get an idea oftentimes of whether that's a problem or not. But firmly, if we're going to say proper, because I have to say every time I hear that word proper, there's on the climate side with electrification, I always hear bold and aggressive, and I'm just like that. Every time I hear that, I want to reach out and strangle someone because it's just wrong. No, you're not going to do anything. You're going to do 4 projects and be like, "Yay, team! You didn't move anything. This is stupid." And so when I hear proper, every time I'm just like, I've come to really dislike that word because if you don't know infiltration, I don't think that it's proper. And that's really hard because also scaling up blower doors, I've just tried. I don't know that we're going to do that. But that's why we've been talking for years. How many times have I mentioned look at past energy use? Like damn near every conversation. Because it gives you an idea. Like I noticed in Cleveland that every 300 therms or so translated to about a ton of heat load. So 300 therms of heating usage, which is easy to figure out. Like most gas water heaters use like 10 therms a month. So you got 500 therms a year of usage, and you subtract out 120 therms for water heat. That's 380 therms. That's probably a ton and a half or 2-ton house. So if you have that as a check figure, and it's going to vary where you are. Like that's going to vary by climate zone and like equipment, like a whole bunch of other pieces. But that's a reasonable check figure that is much easier to get than a blower door. So that's why I'm suggesting that as that. I think that should be a layer, like a check layer, because for the most part, we're not going to have that. I recognize that. I'm a reasonable person, but we need some kind of a check layer if we're going to call it proper. Is that fair?
Yeah. I think that's when I hear people say proper, when I say proper, it's just looking at like from the book perspective, it's being aggressive is the idea of being proper. So if you didn't verify how much insulation is in the attic, don't assume that there's zero insulation or a tiny bit. That's the proper is first off, verify, do something to just double check what you're working with. And then if there's a little bit of uncertainty, be a little bit more aggressive. That's what I mean by proper in terms of like how you're selecting your inputs. I love the secondary layer of have some kind of gut check, have some kind of heuristic. Maybe 1 out of 10 homes do a blower door to like, you get those feedback loops to, or get their fuel usage. Absolutely. But because that's definitely gonna be better than guessing at the numbers.
Yeah, try not to guess. All right, Ed, I'm going to drive you nuts. There's one last piece that I want to hit.
All right, do it.
So you touched on manual S. I'm going to mess with your minds. You know how many times I've run a manual S?
0.
Oh, man, I'm worried about that.
Ever. No, I've never done it. So if you're talking single stage equipment, you better be paying attention to your manual S. But because I've run pretty much exclusively Carrier Infinity systems through my practice, because they had hands down by far the best cold climate performance of anything on the market for years and years until, I don't know, like 19 or 20 when we started getting the mini split based units here. But those have such wide airflow flexibility capabilities that you can run it like it's a dry climate. You can run it like it's a humid climate. You can run it like you're high elevation. You can run it like you're low elevation. And all of a sudden, like as long as your air handler's kind of close, you can make it work. So that is a huge argument to me for truly. So there's communicating and then there's truly communicating. Like it's obnoxious. I feel like, what was that movie? Oh, dang it. But what we have here is a failure to communicate. Cool Hand Luke.
Cool Hand Luke, yeah.
And so, like, I'll be nice and not name the manufacturer, but it is a mini split manufacturer that says that it's communicating. But what I want to see in truly communicating equipment is where, yes, the compressor can vary down to a very low degree, like 20-25% capacity, but you have to be able to match the airflow from the air handler to that. That's my problem here on this system. This Bosch won't get the coil freaking cold enough, and there's nothing I can do about it. So I'm going to rip the damn thing out. I'm going to let a $6,000 piece of equipment sit somewhere. I'm very annoyed by this. Now, it was an experiment to see if I like this equipment or not, and the answer is no. For this application, to be fair. So I'm not saying across the board. But truly communicating, you have to be able to run a cold coil at minimum capacity. That, to me, is how I define it. You don't have to do that technically with communicating, but I haven't seen it done without it. And only a few systems do that. Now, one system that gives me a great deal of hope in this is the Daikin Fit system. So I will call that one out. I've got 2 of them in our Airbnbs. I put 2 little 1.5 tonners in. And those will do a good job with dehumidification down to about 75-degree day. If it's a sunny 75-degree day, the surfaces get warm enough in the house that there's enough sensible load that it will do the latent work, which is cool to see. So like I'm impressed with that system. Below that, you have to have a dehumidifier, which is why I like reheat dehumidification, because variable speed equipment covers a lot of sins and reheat covers a bunch more. Is it perfect? No, but it does a lot. But if you've got a good system, particularly in humid climates, which is 80% of the US, and you can run a cold coil at minimum capacity, like the manual S almost doesn't matter. And then like you got strip heat.
Do you have a great piece of equipment like a Carrier Greenspeed? There's nothing wrong. Yeah. The manual S it's there. It's actually relatively simple. It's so that HVAC professional can look at a bunch of different brands, a bunch of different pieces of equipment and decide, oh, this is going to work great or it's not.
Yeah, I would argue, Nate, Carrier Greenspeed so well because it's a simple calc. You're doing the manual S in your head. You know it's going to do the job for heating, cooling, and sensible and latent. So I think that is one of the benefits of getting to know a certain manufacturer, having go-to equipment that in a climate zone where you operate all the time, like some of this stuff does become ingrained.
You are getting those feedback loops from you're doing the whole process.
So you know you can be smaller.
You're seeing how it's operating and you're like, man, this is working beautifully.
So that too. Awesome. And one other last piece on that. One of the reasons I like hybrids is you can have that safety blanket for the higher capacity, but size it to cooling and see what happens. Because sizing the cooling, like I'm seeing the number 80% on hybrids come again and again, which is how much gas use was reduced, or oil or propane or whatever. 80% reductions by putting in a heat pump that was sized to cooling in climate zone 5. And like I've seen 90 with a couple of my systems. But yeah, being able to size aggressively is key. And that's part of why I say use your strip as your backup. Like this winter here was an incredibly cold winter. We were way below design here. Basically, it was like I moved back to Cleveland because we moved a couple 100 miles south. We used, I think, 800 kilowatt hours of resistance. Chill out. Like this was expensive here because I've got time of use and it actually bit me in the butt. But let's say that's 20 cents a kilowatt hour and let's call it 1,000. That's $200 that the resistance would have cost me. Going out to eat costs $100 now. Come on, like the fear levels that we are feeling over $200. If $200 is going to break your household budget, you should probably be renting and not owning, because you really shouldn't. You should be able to take that kind of a hit. And the fear factor around it drives me bonkers. So you can size a half ton smaller than you think you can, and you're going to be talking about $50 or $100 or $200 a year extra in resistance. And we were 20 degrees below design a couple times, and it was weeks of below design temperatures.
Awesome. All right, Nate, on that note, I'm sure there's 20 more points you could make.
Keep going.
that we want to talk to you about, but we'll have to have you back. Thank you so much for joining the Heat Pump Podcast.
Thank you, gents, for having me. Thank you for building a nice tool. For real. It's a nice tool.
Thank you for giving us a feedback loop and beating the heck out of it.
Yeah, we really appreciate it.
Thank you for catching my errors.
You're welcome. Nate, it's always fun to talk with you. I always learn something new. It's always interesting. So yeah, again, really appreciate you coming on again and look forward to continuing the conversation.
Sounds like a plan, gents. Enjoy the rest of your day and your weekend.
You too.
You too. Thanks for listening to the Heat Pump Podcast. It is a production of Amply Energy. And just a reminder that the opinions voiced were those of our guests or us, depending on who was talking. If you like what you've heard and haven't subscribed, please subscribe in your favorite podcast platform. We'd love to hear from you, so feel free to reach out. You can reach us once again at hello@amply.energy, no.com, just .energy.